Yeah, hi. I'm Aninda. You can find me on GitHub at Space Fugitive and on Twitter at Aninda42. I started programming in the world of C Sharp, where I was developing industrial automation which manipulated robotic arms. So at the beginning, when I started my career, I never used to test. So a lot of things blew up. I'm responsible for a lot of that. And every time something would blow up, the entire assembly line would stop working. So I learned that testing is important the hard way. Um, Another thing I wanted to say is, so I've been working for HP, and then I got introduced to Rails in 2008, and I've been doing it since. I've been in C42 for more than a year now. And another thing is, I'm not from MIT. This is just a T-shirt.
Yeah, so hi, I'm Sidu. I'm Kairen on GitHub, ponnappa on Twitter. I started with Ruby and Rails in 06, which this was my first startup, which tanked, but that's a story for beer. I contribute to our spec. I maintain the any instance feature. I contributed and currently maintain the any instance feature, which interestingly is an anti-pattern, right? So we'll talk about that later. I also wrote the REST HTTP library, which gives you a very cute API for making your HTTP calls. I've also started 2 companies over the years, and I have worked at ThoughtWorks. I started my career at ThoughtWorks. While I was at ThoughtWorks, I started Active Mobs, which was the company that tanked. And then eventually I quit to start C42 Engineering, where I'm currently working. So let's quickly set a little bit of context around this phrase testing. I want to make sure that, it's probably a fair assumption given that this is a Ruby conference, but I want to make sure that we understand that testing is within the Agile context. Testing means many things to many people. It's everything from QTP to, that Mercury Test Center to whatever else. We're not talking about that. We're very specifically talking about testing as it is understood in an Agile context, which is typically what, all of us do. So there are things which, fall into this bucket. Pair programming, stand-ups, test-driven development. So for many people, TDD is not synonymous with testing, which is why I'm just calling this up. So please keep in mind that this entire conversation, this entire talk is within the Agile context where these things are the norm. So let's establish now a few fundamental truths about, writing software. These are broadly true for most people in most parts of the world when they get around to writing software. You start a new project, it's cute, right? It's nice, it's well thought out, it looks clean. You're looking at it, you're like, yes, I can see the shape of this. This is going to be beautiful, right? 6 months later, that's what you've got, right? You've shipped a few releases in a hurry. There were bugs. The customer really, really wanted this yesterday. And there was this other feature that the market really liked that you just did for the heck of it. And now, oh my God, you got to build it out. And then 6 months later, this is what it looks like, right? This is broadly true of many code bases, many places. So working on that code base is kind of like this, right? Like, I don't know how many people have played Prince of Persia here, or am I too old for this? No, oh, thank God. So you remember this particular part, right? Like the first time I got to this, it was always a pain. And navigating a code base which has gotten messy is like this, right? You've got to time things right, you've got to know what's going to go wrong, and when things go wrong, it's like, yeah. So, given that, so that's one part of things, right? Like code bases get ugly, entropy is a fundamental truth of code bases. The other thing is, in the world we work in, feedback is very important. Understanding how things are changing, understanding, how they're changing is about how we work. Like when we write something and it fails, that's feedback. When a customer tells us this is not what I wanted, that's feedback. So feedback is an integral part of everything we do. It's also talked about a lot in the Agile context, right? Agile is all about feedback loops. So you do like small bits of feedback. It's like this cute little kitty nibbling on your finger. It's nice, it's warm, it gives you a fuzzy feeling. Then you take that feedback and then you go scratch it on his head and everybody's happy, right? But this is when you get small amounts of feedback. You're getting it frequently in small doses. If you wait for your feedback and you let it pile up, it's kind of like that, right? It's like a 400 kilo Royal Bengal tiger jumping at you while you're standing in a swimming pool. I'm not sure why he's standing in a swimming pool getting attacked by a tiger, but whatever.
That's the only photo we got.
Yeah, that's the only photo we got. So yeah, so you do want your feedback in small doses, in nice warm fuzzy doses, not in a big fuzzy dose. And so in conclusion, I'm just trying to establish these 2 truths around which much of this talk is based, which is that changing code is tough, right? And that you want feedback loops and you want them to be short. And one of the tools that we've come up with to deal with the first problem is tests, which is what this talk is really about.
Yeah. So tests are an industry established pattern of collecting quick feedback over the code that you're writing. And so the quicker the feedback, the quicker you can fix your problems before it gets away from you. So these are not the tests we're talking about. These are the tests we're talking about. So mostly we'll be talking about unit tests. But getting into the world of testing, once you realize that you need to do testing, the testing options can be kind of daunting. Like when I started, I didn't know what to do. There were like a lot of choices. There's like different testing philosophy, different tools that came to do different things. I really didn't know where to start. So I just asked somebody I knew, I respected, and he said unit tests. So if you're a beginner, if you're confused, just start with unit tests. It's not even if you're a beginner. So even I find it difficult to tell an integration functional test at times, and so it's still hard for us. Yeah, right. So we're not going to be talking about functional tests like Cucumber, Selenium. These are out of scope, mainly because we didn't have time to prepare these. So another thought we had was we're going to look at these tests, and once we started testing, we kind of feel that our tests are not very clean. We don't like using our tests, and we're discouraged to use them. So there are little smells and patterns in our tests that we can iron out, which will make testing a better experience for us and also more effective to maintain them. So these are the villains that we're looking at. These are the anti-patterns, and it's a sexy thing. It makes you want to be the hero, right? So this is our hero. Sorry, Shrishti, you've been at Flipkart for so long, we missed trolling you. So this talk is about testing anti-patterns in unit tests. So there are basically two types.
So we're looking at separating this talk just to have some measure of structure to it into broadly two types of anti-patterns. I'm sorry, can you still hear me? Yeah. Just for this talk, right? It's not that you'll find this written in a book somewhere by an enterprise architect. So we're looking at breaking this into implementation anti-patterns and workflow anti-patterns. In other words, we're looking at anti-patterns with respect to what's in your test versus how the test was written. All right?
So we'll start off with implementation anti-patterns. So these are all things that I've been through writing tests, and then I've figured out these over time. I've had a lot of help online also. So the long test. So this is a test which will typically have a lot of assertions. So ideally, because your test is supposed to fail for one reason, you're supposed to have just one assertion, right? Now, if you have too many assertions, this is the smell, and this is what it looks like, right? You want a phone call, you have a phone call, and you want to hang up the call, right? And look at this last line here. The person who called, his status has nothing to do with ends on hang up, right? So this is a smell. You could possibly rewrite this way. So everything, if you want to update call state, updating timestamps, each of these are separate, and each of the tests correlates directly to the description of the test, which is something that you want to look at. So now you've got like short tests, but now you have like too many tests in your test file. Your test file is like hundreds of lines of code. What's going wrong there? I don't want to even look at my tests anymore. So that's a smell of maybe the code that you're testing is doing too much. Maybe you want to separate out the code into smaller, more singular responsibilities, its own responsibilities, and have test files for those, assuming that one class corresponds to one test file. So the test that has logic. So this is something that I haven't seen too much, but sometimes you'll see smells like if else. This is not a good example, but sometimes you'll see if else in your code. So that's basically logic in your test, right? So the very reason you write tests is to test logic in your code. But if you have logic in your test, then who tests that, right? So that's like watching the watchman. So each and every scenario you would want to separate out into multiple tests and test it like this. I already spoke about that. The implementation bound test. Uh, so when you're testing something, you want to test its behavior and not the way it's internally implemented, right? So this is a very simplistic example. Um, so you have a service. When it starts, you're passing variables a and b to it, and a calls do x and b calls do y. So if you look at the test for this, it just kind of reiterates the code that it should do this. But I mean, this is not really testing any behavior, right? So what I would do here is I would just not write test at all. Sure, my code coverage would go down, but so code coverage is not the goal, right? You just want to make sure your test behavior. That's the very reason you're writing tests. Test with arcane terminology. So sometimes, have you ever looked at a test file and gone through the test descriptions and said, I have no idea what this application does. It's just crazy. So you have to remember that while you're writing tests, and when you've written a test, you know what the test is going to be doing, and it'll all come back to you when you look at it again. You're going to be working with other people, and other people, when they look at these tests, they should be able to say, just by looking at the name of the test, what that test does, without having to go through how the test is implemented. So the name description should say it all. This is developer documentation, and anybody who's rolling onto a project will love you for it. So comment is basically a well-named test. So early in 2000s, I was encouraged by people to write more comments in my code. I have since realized that if you want to put a comment in your code, because your code does something complex, then there should be a nicely named test for it. That's something I found helpful. Okay, slow test. Like when Sidu spoke about feedback, we need feedback fast. If we don't get feedback fast, we will be discouraged from running tests at all, because people say, hey, this eats into my testing time. I don't really want to do that. So why does this happen? So sometimes you have too much data set up in your tests. So data heavy tests will take longer to run, obviously. We'll get to that right after this. Too many objects. Again, this is something that I haven't seen too often, but I just thought it should be there. So while running your tests, if you cause garbage collector to run because you have too many objects in memory, then maybe you should profile your tests and fix those issues. Make sure your tests don't wait till your garbage collector finishes. So if you're testing externals, you're testing across system boundaries, and this is not something that you should be doing because you don't have any control over these. You should stop testing these, and you should stub externals that your code calls. This could be writing to a file system, calling an API. This is something that you don't care about. Okay, so Rails startup time. So lately, after switching to Rails 3 and 192, it's become a real pain to run tests. So what we do at C42 is use Spork and Guard, right? So Spork will preload your test Rails environment for you, and Guard will reload it every time a dependency changes.
So how many people were already using Spork? Not bad, like a decent percentage. So a lot of people running into the 192 slowness.
So Guard will manage your dependencies. Suppose you change your gem file and you want that to reload your environment, or you change your factories. This will basically do it for you. Yeah, this is something that we said we'll come back to. So test that has complicated setup. So the way I think is fixtures is for static data only. So if you have an application and you have like 5 states for an application, and that's never going to change, that's good for fixtures. But anything over and above that, I wouldn't recommend you use fixtures for. Large factory setups are better than invisible fixtures. So even if you're setting up a lot of data, if you're setting up that scenario of the test in your fixture file, that's invisible to you. So somebody looking at the test wouldn't know like the data dependencies related to the test. It's better you just create a lot of factory objects here, so you'll be able to tell from the test what is exactly going on rather than create fixtures. Stub non-essential factories, right? So this is So in Ruby it's kind of structured like this. So you have like a lesson, and you have a lesson belongs to a chapter, chapter belongs to a book, and book belongs to a should be author. So and you want to render that lesson only if the author is a verified author. You don't want you want to control quality. Uh, so you could create like the whole association, uh, which would not be a good idea. You should just stub it instead. So this is still a smell because the smell is not a test smell. The smell is an architectural smell. So you might want to denormalize the database or something like that, like have trusted lessons or whatever you want to do. But from a testing point of view, this is still okay. All tests should execute independently as well as a suite. So basically, you should not share state in between your tests. If you're sharing state in between your tests, you can probably run that test independently. But when one state before, when one test before would have already modified state, and the test after would not be expecting that modification, that test would fail, and that's not a good thing. So test must not share state. Avoid redundant replicated tests. So this is something that I faced while writing tests for controllers. So a lot of times I felt that the test that I have written for my controllers is basically the same test that I've written in my model. So why should I write them again? So the answer is don't. So how do you know which test to write and which test not to write? So the recommendation I got for this is try to push a higher order test, lower down the order, and if the name doesn't change significantly, then it should be a lower order test and you don't need a higher order test. Test that shows high churn. So sometimes you'll see a lot of commits on a particular test file, right? That can happen basically because of two reasons. One is that you have requirements churn, right? So your requirements are changing, therefore your tests are changing. That's like a whole different problem altogether. But if you don't have a requirements churn, then you are basically depending on this on the code that your test is testing way too much, and you should find a way to refactor that, have it more loosely coupled so that different tests hit it rather than one test file. Tests that cannot fail. So this is a common problem. This has to do with false positives. But so the way you solve that is to make sure you fail your test first. This is something that Sidu is going to be talking about a little later. Yeah. So over to Sidu.
Yeah. So now I'm going to talk about workflow anti-patterns, which are anti-patterns in how the test is written rather than what's in the test. So what Aninda talked about thus far was like different ways in which you can end up writing tests that will have problems or cause problems or are indicative of problems. This is going to be more about productivity, if I can put it that way, than anything else. How do you make sure that you are getting the maximum value out of your tests from the way in which you write them, right? So this is the most common waste of effort in my opinion, which is that you're writing the tests but you write them last, which sort of removes half, maybe more of the value of writing the test in the first place, right? So the thing about tests is they're as much a design tool as they're a regression testing tool. Most people look at tests and say, well, this is the name of the test. It's called a test, therefore it must be for testing. Now, this is something that the behavior-driven guys kind of try to fight against by changing the word test to behavior. That's literally what they were trying to step around. The perception that writing tests is primarily about testing. It is about testing, but it is as much about writing good code and using your test to figure out how to write good code as it is about regression testing. And the best way to work around this is to rigorously follow the red-green refactor steps that Aninda was talking about. So you always, step number one, single most important rule when writing tests, start with a failing test, right? You write a test, you don't write any code, you write a test, you run it, it should fail. You want that red, right? Once you've got that red test, you know that this test fails in this condition. Honestly, I've had enough cases where the test was always green and I didn't do this, and then I regretted it later because I had a bug and the test never caught it. Like, what was the point of writing the test if it didn't fail? So make your test go red. Next up, Make it go green, that's obvious, right? And then finally, clean up after yourself. Now that you have a test protecting you and telling you, look, your code works. Now you can go and change your implementation to make it cleaner. An interesting thing is you can't do this if you fall into the implementation pattern, the anti-pattern that Aninda was talking about, which is the implementation bound spec. If for some reason your test is actually coupled to the way in which your code works, you can't refactor, because refactoring is about changing the implementation of your code without changing the outcome. So red-green refactor is a brilliant rule. Follow it rigorously. It will also help you identify and step out of implementation bound specs. But there is a slight sort of 1.1 version of this that I like to call out more explicitly, which is red, green, commit, refactor, commit. If you think this makes things noisy, that's fine. Like, don't worry about it, because you can always do is get squashed later, right? But this kind of mechanical, process following gives you a sense of, gives you a better sense of how to write tests. And over time, you'll be able to step out of like this kind of fine-grained stuff, but it gives you a comfort which is hard to describe until you've experienced it. So that's it for the red-green refactor. Testing only for regressions. So I talked about this briefly in the previous point, but usually what happens when people are testing for regression is they're testing lost, right? Often, and I'll talk about this later, the testing isn't even done by the same team. So this is an anti-pattern which you can combat by using red-green refactor, but you have to remember that your ultimate goal with any code is to write maintainable, well-encapsulated, loosely coupled code, right? And TDD is an excellent tool to help you do this. So make sure you're using TDD to make this happen. Now, why does TDD allow you to do this? So TDD is a special form of unit testing, right? Now, in unit testing, it's implicit that you're dealing with units. Now, most people say, hey, I find it hard to write tests. In most cases, if you look at those situations, you'll find that it's hard to write tests because the code that's being tested is not a unit, right? How did that happen? How did the code not be a unit? Because the test was written after the code. If the test was written first, you're forced to write a unit of code. You can't write more than the unit because you don't have a test for it, right? So keep in mind that TDD is a tool which allows you to break your code up into tiny chunks, keep it loosely coupled, keep it well encapsulated, and use it for that. Testing elsewhere, okay? This is when people that are writing the code are not doing the testing. You'll typically hear this in subtext in terms. You'll say, oh, my QA team writes my RSpec, right? Or, hey, I don't really want to do these. I'll give it to my teammate. I finished the story is done. I finished my features. My teammate's going to finish the tests, right? So testing elsewhere is an anti-pattern because it separates, the team into testers and developers, which means that, again, going back to the point I made in the previous two workflow anti-patterns, you're getting only regression value. Even there, I mean, it's questionable how much regression value you're getting because the person that's writing the test does not understand exactly what the code does, or at least not as well as the person that wrote it, right? So you do not want to have separate teams of testers writing unit tests. This is a complete no-no, right? Shy away from this. Next one, only run rake, right? This means that in your workflow, when you're writing code, you only run rake. You never run one test or one test suite at a time. You write your code, you go to the command prompt, you run rake. This means that you're typically running anywhere from 10 tests at the beginning of a project to, I don't know, several thousand in a larger project. So you're never working on just one unit here, right? So that's a huge problem. You're only looking at the overall regression output for your entire project. You're not test driving your code. This again comes back to a smell that tells you you're not doing test first, right? You do not want to be just running rake every single time. What's the other problem with just running rake? It takes time, right? If you're taking time, it's going to make you less inclined to run. You'll be like, oh, screw it. I'm going to sit here, I'm going to write all my code, and when it's time for me to commit and push, that's when I'm going to run rake, right? So you want to reduce those kind of, delays which make you less inclined to run your tests. You want to make it so easy that you're running your tests all the time. So what you want to be is in a situation where you can run one test, multiple tests, whatever, and you're doing it all the time. So, of course, there's the other thing which is never run rake, which is the scary cowboy, right? Like, I don't care about my tests. I'm just going to commit. I wrote something, I wrote some tests. My tests work. I don't care about anybody else's, right? So this isn't the same problem, like you are running tests, but you're only running your own tests. but you're committing without running rake. So you don't really respect what other people are contributing to the code base or what require. So your tests are basically requirements documents. And what other people have written as tests are what they interpreted as being the requirements. If you don't run them, you're saying, I don't care what you guys think. What I care is important. I'm just going to commit and to hell with the rest of you. Right? Without CI, and this is why CI is important, right? You're going to be in a world of pain. Now, CI is a good way to prevent this kind of pattern emerging in a team, but more fundamentally, I think, is just good manners, right? It's just basic etiquette to say that before I commit, I will run rake. I want to see what everybody else has done. I want to see if I've broken somebody else's stuff, and I don't want to waste somebody else on the team's time by forcing them to fix crap because I was being rude. So the last, I think this is the last one. I'm not sure. Yeah. The last one is only running tests from CLI. Now, this is not such a big deal because, you're still running your tests. You're able to run focus tests. I don't know, like how many people are familiar with syntax for mini test or RSpec to run, one test, run tests which are in this line, run this scope. Not bad, like I see a lot of hands. So these are important things for you to be familiar with, like for those of you who aren't, just check it out. It's pretty easy. It's very convenient to be able to run just one test. It's an important part of being able to focus on one unit because you want to just run one test, right? Your entire development cycle should be, hey, I'm running this one test, I'm writing the code for it. I'm never running more than one test at a time, except when it's time to commit, right? But running it from the command line tends to slow you down a little bit. You always have to switch to a terminal, look up the line number, put that colon, put the line number, then hit enter. So try to avoid running your tests from the command line. Try to set up your development environment, your editor or your IDE, whatever you use, RubyMine or Sublime or Emacs or whatever, to allow you to just run the test that's under your cursor. I don't know, like how many people have their environment set up so with a keystroke you can run whatever test is currently under the cursor. Yeah, fewer hands go up. So try it. Like you'd be surprised at what a difference it makes to your life. It's a simple configuration. It works on Vim. It works on Emacs. RubyMine definitely does it. TextMate does it. Just set it up. It's a trivial thing, and see what a difference it makes to your workflow. Like suddenly, so much, and it's ridiculous, right? You think that this shouldn't make such a difference, but it does. Suddenly, your workflow will be easier. You'll run more tests. Life is better. Small kittens, furry kittens, not Royal Bengal tigers. So, we did have more. Good. Okay. So this one is probably the hardest one for me to get used to, right? This is a longest story. I don't know if I have other points there. Sorry, excuse me. Yeah. So sorry. So this is a function of us not preparing for this talk for more than 2 days. So yeah. So this was the hardest thing for me to get used to. I learned this on my last project in ThoughtWorks where we didn't have a QA team. Sorry. Okay. Cool. So this totally freaked us out. And we had a hard time adjusting until we realized that even without a QA team, at least from a business logic, maybe not from a UI, but from a business logic and workflow perspective, we still didn't have any bugs. If you don't have bugs, you don't need QA. The reason you won't have bugs is if you're doing your testing properly, comprehensively, you don't have bugs. You don't have bugs, you don't need QA. This is one of the hardest but most liberating experiences you can have because it builds a mind-blowing amount of trust in your code base. Right? You're trusting your test suite to give you complete feedback that you typically depend on a QA team for. Free up your QA team. There are a bunch of smart people. Let them go do exploratory testing, go figure out, whether this is meeting customer requirements, whatever. Stop having them waste their time clicking through applications, checking if you've done something stupid. That's what your unit tests are for, right? At least on the business logic side. Quickly running through, test should be enough. No CI is, I hope, the last anti-pattern. You want to test after every single commit. Right? And that's what your continuous integration server is for. So how many people have seen a continuous integration server or are using one? Not bad, like a good spread. So try this, put this into your workflow, make sure that every single commit that you make as a team is going into continuous integration. And then, this gives you excellent feedback if your team is split up, like if you're across countries or across cities, it's awesome. And then remember that CI servers are not, technical tools as much as they are collaboration tools. They're a way for a team to communicate with each other effectively about what the status of the code base is. If you have a largish team, like don't even have your CI server send you emails. Make sure you have like a nice loud sound come from your CI server. Like set up a box in your room, have it play a loud sound when your build fails. And you'll be surprised at what a difference it makes to your workflow. Alright? And this is my last point. I remember this is definitely the last. You don't want to be doing manual deploys to staging. So how many people here have, the usual staging pre-prod prod split up in their projects? Most people, right? Yeah. So what you want to do is to ensure that every single commit that has all tests passing goes to staging. This works in two directions. One, of course, is that your customers or whoever are your customers, whether it's within your company or your consultancy with clients, they're getting to try out whatever you're working on an ongoing basis. The other direction is that it forces you to have a higher degree of discipline in your testing. Because if you don't have good testing, you don't write good tests, you're going to have your stuff going to staging and you're going to have it break. Right? You are just going to be that much more careful because you know people are going to use the stuff you just wrote. Every single commit. Right? So that's kind of why manual deploys to staging is an anti-pattern. Try to set up a CI server, then have your CI server auto do cap deploy on every passing build to staging. I mean, it's staging after all, so what if you screw up, right? You're like occasionally you'll be in a situation where your tests don't catch a bug. So what? The rest of the time, the value is awesome. So yeah, reading between the lines, quick summary. This is kind of the I'm not going to say it, moments you have when you hear people talk about stuff on the internet. So you need to be a little careful about this. So I'm going to talk about, what people say and what it actually usually means in these contexts. So, and it's almost like a caution, like listen to these people, but look for the subtext. So we do BDD, not TDD. What this usually means is we only write queues, right? No unit tests, no test-driven development. We only write cucumber specs. We have 100% code coverage, but it's usually only from queues, right? 100% code coverage from queues is worthless. Like it means very little, right? You want 100% code coverage from your unit tests and that to split so that you're getting coverage separately for models and separately for controllers. Because otherwise, just one queue could probably give you 30% coverage. That's ridiculous. Like that's useless information. We love our tests, and then somebody will say, but we love to write them, like run them once a day. Like when people say they write tests, you also need to check the frequency, which is why so much of the workflow part of the talk was dedicated to, enabling you to run tests more and more and more frequently. So an important aspect of saying, yes, I do testing, that's great, but how frequently do you run your tests? How small is your feedback loop? We keep our build green, but we comment out failing tests if necessary. Like you'd be shocked how often I've seen this. Like what use is a green build if the tests have been commented? And this is the last one, promise. Tests are an integral part of the way we work. We will write them for every client that wants them. Right? I would have 5 rupees if I charge 50 paisa for every time I saw this. So yeah, those are attributions, lots of pictures in the beginning, and after that we were in a hurry. And questions. Yeah.
In Rails, like for the active record, we put a lot of variations for the attributes.
Sorry. Could you repeat?
In a Rails project, right? So you have a model. Suppose the model has 20 attributes. So you have a lot of validates. So typically in that case, in my experience, like the test becomes long because you have 20 attributes, means maybe there are 40 or 50 tests. In a file, there will be a lot of 100 tests.
Sure.
So do you consider that as a smell, or is there any recommendation for that?
So that's the hard problem with such questions, right? It actually just honestly depends, right? So my first question would be, is that a code smell? Why does your active record have that many attributes, right? Most well-factored objects. So the thing with active record, it is still a 1:1 correlation with your domain model. Most domain models that have more than a handful of attributes, like 3, 4, 5 maybe, are doing too much, right? I've rarely seen a well-factored code base with more than 5 or 6 attributes on any model. So the first question I would ask is, why do you have that many attributes on a model? I've occasionally seen code bases. I think one story I heard, like one model had 100 attributes, right? But that was very clearly a case where it wasn't a domain model. It was a reporting situation. It was like a BI table. They were using Rails almost as an enabler to generate reports. It wasn't a proper object model. So 2 parts to the answer. 1 is it depends. 2, is it really a testing smell, or is that your tests telling you, the too long test file telling you that your code is poorly factored? Right? Did I answer your question? Okay. I saw a hand go up here.
Hello. Yeah, sorry.
Yep.
So normally in any complex domain, right, you get a lot of corner cases that you can't always conceptualize at the beginning. So you don't always know which tests you have left out from
Sure.
writing. So would you call inability to conceptualize the corner cases a code spell as well?
Probably not. At this point, I'm just going to channel Steven and something he told me like 5 years ago, which is your tests are only as good as what they test. They are never going to be comprehensive, right? The fact that you've written your test does not mean that your code works. It just means that your code works for those cases. That is the reality of the situation. Deal with it. Like you can never sit and conceptualize every single corner case, right? When a corner case crops up, it'll crop up as a bug, right? At that point, you write a test for it, fix it. But if you sit and spend so much time trying to think about everything, you'll never actually get anywhere. Which is kind of why also we talked about how regression is just half the story. The other half is design, right? So if you focus completely on regression and say, I want a comprehensive regression suite, you'll never get it done, right? Does that answer your question? Cool.
Is there any clear distinction in the way you write or in your testing infrastructure for a library as opposed to an application?
Good question. So the only thing I can think of off the top of my head is that most cases in a library, I don't have to deal with all the complexities that come with having a view, right? So you usually have a certain measure of weirdness going on because controllers are not really an object model. Controllers are orchestration, and controllers plus views always clear the pitch. If you see most of the debates around testing, you'll see they center around how do you test controllers, how do you test views, right? So if you're doing a library, it's pretty cut and dried. You have queues, you have your unit tests, you have. This is actually an interesting point. Like just one project that I looked at, I saw a 1:25 or a 1:30 ratio between queues and unit tests, right? So yeah, I would probably say that's it. Like you don't have to deal with a view, but otherwise it's more or less the same. Nothing else. Yeah, fair enough. Yeah. Sorry if nobody caught that. A similar proportion from controller to model tests. So you always, so when you have a full app, you always have, you know, the most unit tests, fewer controller tests, and then fewer still, you know, Selenium, Cucumber, whatever it is. So that's the ratio. If you have it the other way, then you have the problem that you have too many queues and you're not actually unit testing your code.
We take 2 more questions.
One hand up here from that time.
So for someone, my name is Mitesh. For someone who's drudging his way into just learning Ruby and Rails, what would you suggest? You know, should we start off with directly TDD, BDD, and get going, or should we first get the constructs right, get used to the coding, and then move on to testing and TDD?
So are you new to programming entirely?
Not at all.
You're an experienced programmer.
Yeah.
I would say figure out how to do TDD in the language you're already comfortable with. These are 2 separate questions. So it's like, should I learn TDD and should I learn Ruby and Rails? Split them up. If you're already familiar with Python or Java or whatever, learn to write test first in that language. All these languages have fantastic TDD infrastructure. Once you've learned it, that's translatable across any OO language. It doesn't matter.
Cool.
Also, once you're learning something, if you write tests for it.
Sorry, I didn't get you.
If you're learning something, if you write tests for what you're learning, it's a nice way to learn also.
Right. So you mean that I can also start off with TDD plus raw right away?
Yeah, they're completely disconnected.
Right. Got that. Cool.
Right, one last question.
Okay. Too much of stubbing, is that a smell? Because I see a lot of code bases where they stub almost everything. I just don't see the point in doing that.
So stubbing is bad. What's worse would be if you see too many mocks. But yes, both are a smell. And usually you'll find them overused in implementation bound specs. So if you notice the example Aninda put up for implementation bound spec, it was entirely mocks. And what a mock really tests beyond, so if you have, usually the pattern you want to look for, the very specific smell you want to look for is multiple mocks chain, right? So A should receive this and return B. B should receive this and return C. C should receive this and return D. This basically means you are asserting against your program execution flow. You're asserting that this method calls this method, calls this method, calls this method. You don't care about what those methods do. right? Whereas that's the exact opposite of testing behavior, not implementation. What you really care is what's the outcome. I don't care whether there are 5 methods, 10 objects, 20 objects. It's completely irrelevant to me. I care that the output comes out. Because if you do this, you can't refactor your code, right? Stubs have an additional problem because they don't assert, but they obscure because they give you like these fake values. So you don't know whether your code behind that stub actually works or not. So you better have a test somewhere else. You're not really sure. So usually you'll see this in a separate layer, right? So you have a model and which actually works in the model has unit tests, but in your controller you've stubbed or mocked your stuff. The problem there is if your model code changes, you've changed your model test, but your controller tests won't break because they're stubbed. So the problem is you basically have like this weird mimicry going on where your tests are trying to pretend they know what's going on in the models, but they actually don't, and they don't fail. So it's just extra work and extra risk of bugs cropping in. Sorry? Yeah. So that's actually a very, very good rule of thumb. Like try to stub and mock at system boundaries. Don't stub and mock within system boundaries. Right? I mean, it's a generalized rule, so it may not always be possible, but it's a good thing to try to adhere.
Right, so that's all the time we have for.
Cool. Thank you so much.